Hello, everyone. Thank you for attending my keynote at WOOT this year for USENIX 2020. I'm very pleased to be here this year. WOOT and USENIX have been one of the series of conferences that I've admired the most, and I'm honored to have been invited by the committee to speak to you all today. In this keynote, I'll talk to you about one of the topics in security that's been one of the nearest and dearest to my heart, which is OS security, and specifically what we can do to make that better. In this keynote, I'll talk about how OS security is hard and why simply writing a better fuzzer isn't going to get us to a place where things are meaningfully going to change, at least in my opinion. And that may be a bit of a controversial topic for a conference focused on offensive technologies, but I hope you'll bear with me and my hypothesis here. So just a little bit about myself. I'm currently a VP of Endpoint Engineering at CrowdStrike. I've been there for about 9 years, since the beginning of the company. And previously, I worked at Apple on the iOS core platform team. To some of you, I'm probably more and better known as a co-author of the Windows Internals books, which I've been a co-author from the 5th edition onwards, as well as being one of the key members of the ReactOS project, which was, and still is, an open source project meant to re-implement Windows from the ground up as an open source project. I've tried to use most of my Windows knowledge to help educate people, both through articles, blogs, tools, utilities, and dozens of conference talks. Obviously, in the last couple of years, I've been using that knowledge to help build the product CrowdStrike, but I still very much greatly enjoy the open source community and doing research and just talking and meeting with people, or being here in this virtual format as current times have kind of forced us to be. So I've been in this industry for probably about 2 decades now, and I've seen it evolve, especially the way that the bugs are tracked and taken into consideration. For example, in NT4, ancient dinosaur operating system, Mark Usinovich, famous, I guess you could say researcher back in the day, although he just said software developer, who today just happens to be the CTO of Microsoft, released a tool called NT-Crash. And this was a tool that performed about 100 system calls, passing a null pointer to each of them, and crashed Windows NT4 in 100 different ways. Microsoft responded to that by slowly, over time, releasing service packs that gradually, up until Windows 2000 came out, fixed these crashes. Mark then released NT-Crash 2. Now, NT-Crash 2, instead of sending null pointers to these system calls, instead sent 1. And so today you might call that an advanced polymorphic fuzzer. Back then we didn't even have that word. And Microsoft eventually fixed most of the bugs through some of the service packs to Windows 2000. In fact, when they fixed these bugs, they didn't even release vulnerabilities or CVEs or anything like that. They made marketing blog posts saying how, oh, this tool no longer works. And it wasn't even a security tool. NT-Crash was considered a reliability tool. And they're talking about how Windows 2000 Service Pack 5 is now more reliable. Now, things changed quite a lot with the introduction of Windows XP Service Pack 2, the famous Bill Gates memo, and the creation of the SDL, or Security Development Lifecycle. With that, Microsoft then, as part of the various security undertakings that they took, including taking the MSRC to the next level, significantly increased the security of the operating system and introduced completely new ways for developers at Microsoft to interact with the code and to write new code. Now, the other thing that happened around that time frame, thanks to the work of Katie Masuris and others, was the creation of bug bounties at Microsoft, including the very first bug bounty for remote code execution vulnerabilities in Internet Explorer. Now, for the past 3 years, this bug bounty program has gotten to the point where finding a simple information leak or an info leak in Windows 10 preview editions or vNext or WIP builds would get you $10,000 US if it was a well-submitted, thoroughly documented vulnerability. Now, this actually since last week has now been decreased to $2,000 in the vast majority of cases. But it's been an interesting journey from marketing blog posts over 6 years for something that crashed the kernel to $10,000 in your bank account for leaking a kernel pointer. In this talk, though, I want to focus on the little bit of the bug bounty economy and how I see that, this idea of InfoSec schools, which is kind of related, and then dig deep into why I think the current mitigations and tooling that we're coming up with are solutions. And I'll show you some examples of what I mean by that, with some parting thoughts on where I hope the industry can head to. So let's talk a little bit about the bug bounty economy. Now, finding bugs wasn't always that obvious before. There were few, if any, automated tools. There was little knowledge in the community on how to find bugs, and bugs that exploits or POCs didn't really mean much. The know-how on how to exploit and techniques such as ROP weren't really known. And because there wasn't a legitimate way of submitting bug bounties and vulnerabilities, most of the efforts that went into these areas typically went to black market operations and brokers. So we should really thank the work that many people have done that got us to today, where we have coordinated vulnerability disclosure, bug bounty programs, tooling, talks, conferences, and this amazing InfoSec world that we live in, with its charms and its flaws, of course. Today, Microsoft, Apple, Google, Facebook, Amazon, you name them, have hundreds of programs for bug monies and have paid millions and millions of dollars. Microsoft alone recently announced that in the last financial year, they've paid over 35 million US dollars in bug money. BugCrowd, HackerOne, and other platforms automate the discovery and triage and community aspect of the process, which I think has reduced the effectiveness of black markets, or at least increased the cost that these places have to offer to make themselves competitive versus the legitimate route. BugCrowd alone, for example, in November of last year, indicated they paid out over $500,000 in a single week, which is just astounding. Also, Microsoft used to, and most vendors used to fix bugs in years. Today, they'll usually fix a bug in 1 to 3 months. If you give them a 90-day disclosure deadline, they will usually stick by it. So we're finding all these bugs, or paying for all these bugs, but what kind of bugs are we getting? Is code getting buggier? Are these bugs really complex chains of iOS-like jailbreaks? Not so much. It turns out you can make anywhere between $500 to $1,000 just by finding a cross-site scripting bug. Pop a message box. There's now automated tools that allow you to find these types of vulnerabilities and basically find at least 5 a month guaranteed. Find a few obscure subdomains owned by a company, new website launch, some third-party vendor that wasn't correctly configured, and just keep submitting the bugs on HackerOne or BugCrowd. So on average, the bit of luck and the right tools, you can probably make $2,000 a month. Let's say $2,500 a year. Now, in a lot of industrialized countries, that's probably the salary of an intern. So when you're starting out, yeah, sure, this makes sense. Obviously, to those of you that are professionals in the field, making $25,000 a year is in an industrialized nation is probably not going to feed the family. But in a country that's still in development, such a salary can be a lot of money. In fact, in some places of the world where there's very smart, highly talented, highly educated people, we're talking that being 5x what a professional software engineer might make. So the economies there get kind of interesting. Now, we keep talking about the shortage of qualified software developers, and there probably is one. And so what do we do in industrialized nations? Well, we go after and we outsource in countries that have a high degree of STEM talent, but much lower pay. China, Romania, India, Israel, it's probably a myriad of others. But people in those countries, just like in other countries, can now make more money, way more money, by finding bugs instead of getting outsourced to some multinational American company and writing code. Why make $6 an hour writing code if I can make $2,000 a month just letting a tool run on some server that I've built from spare parts? And even worse, who cares about the outsourcing? What about the local companies in those countries? The ones that want to innovate and hire local talent and build local products. Not only now do they have to compete against vast global multinational companies, but they also have to compete against the bug bounty money that is increasingly incentivizing people not to write code, but instead to break code. And we do need breakers, to be clear, but where's the incentive to create? Now, there's a complete lack of resources in terms of actually fixing the bugs that are found. If you look at the bug trackers for projects like Drupal, 7-zip, Notepad++, they're chock full of vulnerabilities, but nobody's had to fix them. The developers usually prioritize feature creation and feature requests. That's the truth of software engineering, and it permeates even in open source work. There just simply aren't enough developers to fix all the bugs, again, especially in the open source world. In some cases, developers may not even want to fix the security bugs. There's some famous developers out there with questionable practices where, they'll say, oh, ASLR slows things down. Oh, no execute protection causes app compat problems with this plugin from 1994. I'm not going to use that functionality. But you know what? It's okay. The government's going to step in and fix this. Because in some countries, like in Europe, for example, there's now government bug bounty programs to fix all the bugs in these open source projects. For example, some of them can get up to €1 million now for finding bugs. But nobody's getting paid for fixing the bugs. Nobody's getting paid for triaging the bugs. And so bug bounty programs are great, don't get me wrong. They're great at surfacing bugs, but they're not making the code less buggy. They're not increasing the quality of the code. They're just surfacing all the problems. Because unless you have developers to fix the bugs, things aren't getting better. And sure, Microsoft has the resources to fix those bugs. An open source project doesn't necessarily have those resources. And if we're only paying for the breaking and for the finding, but not for the fixing, that again creates, I think, some economic disequalities. Now, not only is the current state of the bug bounty and InfoSec world highly economically incentivizing one aspect versus the other, but the schooling system itself has started to change. There is now more and more schools and programs at schools which only teach offensive security and bug finding. And again, I love offensive security, but a school that only gives you a degree in offensive security, not a master's, not a technical degree, but you come out of high school and your computer science diploma is actually an offensive security diploma where you've learned how to set up Kali Linux and hijack a bunch of websites. Cool skills to have, but is that really computer science education? Now, you're finding all these bugs, you're getting paid lots of money, and people 2 generations older, probably the parents of these kids going to these schools, making half the money, are now fixing them. That generation is eventually going to retire. And if the current generation only knows how to find bugs, who's going to be left to write code? And are the people that are left going to be the people that we want to be writing code? Now, it's not just commercial schools. There's countries where there's entire government programs dedicated to taking kids out of school, paying them money to go through an offensive security program, including flying in third-party researchers and developers and bug finders from around the world, and basically teaching these kids how to find bugs, how to find vulnerabilities, and teaching them things about ACPI and Hyper-V and rootkits, and throwing in some PHP in there. And then when they're finished with these programs, the best of them get to go in pre-reserved government-owned slots in various large companies within those countries. This isn't some sort of dystopian future. I've taken part in some of these programs, some of these countries, which again have their place, but it is a little bit scary that that is where the kind of the education side is heading. And so we're seeing this economy of finding bugs. We're seeing this schooling focused on offensive security and on finding bugs alone. Where does that lead us? Well, let's look at a few examples that kind of worry me. Now, one of these examples I presented a couple of times last year. And, you know, it's been brought up how I kind of harped on this and made a big deal out of it because it's a very, very simple example. It was a system call, right? It was a piece of kernel code accessible from user space. Unprivileged code could call in this function. And what you see on the slide here is the extent of this function. I was not hiding anything. I was not removing any validation. It simply took an index as an argument, dereferenced it in a statically sized array, and returned some data in there. And you can ask pretty much, probably even a computer science student, what is wrong with this function? Let's say it runs in the cloud, let's say it runs in the kernel, let's say it runs in a different context, and most of them will say that index should be checked. Now, a lot of people thought that I was trying to shame the developer who wrote this, or make fun of the fact this went in. I mean, sure, it's kind of funny / sad, but it happens. Now, people also said, look, this is just one example. It's a recent example, yes, but it is a one-off. And that's where I'm like, well, is it really a one-off? Because the point definitely here was not to make fun of the developer of the process. It was to investigate what could lead to code like this appearing in new versions of Windows, for example, whereas 10 years ago, this probably would not have happened as part of the SDL. I also wasn't trying to bash Microsoft with this example. It was an example in a OS that I was familiar with. But let's look at a very similar example that has nothing to do with Microsoft. Here is a piece of code that was found in WebRTC by Google Project Zero. WebRTC is a internet standard for real-time video. This is in the VP9 codec. Now, this bug is a little bit more complicated, a little bit more code, but some of the most important lines of code are on the slide here. And suffice to say that there's an array of a static size, 5 here, and this parses some of the frames in the video, and then dereferences without checking the bounds inside of this array. Now, the bug is that when building the index values, they use 3 bits. 3 bits gives us 0 to 7. Obviously, the array only has 5 entries in it. So entry 6 and entry 7 would overflow. Now, this bug was fixed about 2 years ago. But interestingly, there's still no assertion in this loop. This loop still assumes that whatever indices it gets, even though there's 3 bits, and even though the variable is a size t, it still assumes to this day that the values are going to be between 0 and 5. And they are, because the bug was fixed. But if someone else later adds code that, again, makes values larger than 5 possible, or 2 other values that can fit in there, this is going to break again. And the fact that there's no assertion here kind of just rubs me the wrong way. And I'm sure there's people out there wondering, what's an assertion? Because that's something you would learn as part of being a developer and writing some code. So this was fixed by focusing on the fix, not necessarily by focusing on the overall engineering of the code. And you'll see this in many, many companies where a fix is all about minimizing the impact, reducing the lines of code. Now, for another and more recent Microsoft example, there's about a half dozen different system calls that Walid Asar has been fuzzing, actually. So he's found these with a fuzzer. And there's actually another set of 5 bugs that he is looking into as well, perhaps even more, around partitions, on top of PE parsing bugs that he's found. So he's fuzzed the PE parsers, and now he's fuzzing system calls. Now, this one is slightly a bit more code, so I have removed some of the things here that were not relevant, but obviously did not remove any security relevant checks. And suffice it to say that there is a check for length. If the length is not 0, then a pointer is validated. In Windows system calls, when you receive a pointer, you need to make sure that it is a user mode pointer and potentially that you can access it. So this violation here we can see only happens if the length isn't 0. Then the actual worker function gets called, create enclave. And if this worker function succeeded, then we write the result back in base address. Now note that the write of the result in base address is unconditional as long as your success. We don't actually check if info length is 0. And there are success paths where even with an info length of 0, create enclave will succeed. And when it does, the kernel will write in base address, which if you, for example, passed in a kernel address, will result in a semi-controlled write into anywhere you want into kernel mode memory. This was found by a very simple fuzzer where the first parameter base address was probably null when Waleed first ran his fuzzer, and full length was 0. A few of the other arguments were large enough, sufficient enough to pass validation, and probably happened in blue screen of death. And he also found a null pointer reference that in this exact function as well, and a few other similar functions too. So again, fuzzing is actually a great thing. That's how these bugs are found. But why are such simple, relatively bugs being added to system calls? Interestingly, this function, which was added in Windows 10 threshold 2, was not vulnerable initially. Initially, info length could not be 0. That's because this function allowed you to create Intel SGX enclaves. I think there's a talk about SGX later on. Later, in Windows 10 19H1, it was updated to also work with VSM enclaves. By doing that, some of the code got rejiggered, and as part of that rejiggering, well, as you can see, a bug was added. Something a little bit more timely. CVE 2020 LEET 1337. This is actually a redux of the print daemon vulnerability that Yarden and I talked about. Now, that original bug, which was a collision with some of our friends from Safe Breach Labs, was all about the fact that the print spooler had a client-side file system validation check. That was then moved as part of the fix to be a server-side file system validation check. But the problem is that when they did that, they forgot about symlinks and other types of file system redirection attacks, which basically meant that now it was still vulnerable and could be fooled by a symlink attack. And that's the bug that I submitted along with Safe Breach and probably a few other researchers as well, yet again colliding. And it was surprising because Microsoft was in the middle of dealing with a crisis of file system redirection attacks, so much so that it ended up making them out of scope. And so in this realm of knowledge that file system redirection attacks were happening all over the code base, they make a fix, 2020 1048, which ended up being vulnerable to a file system redirection attack, which then had to be fixed in the second CVE. So all these are obviously understandable mistakes. The first example was because the fuzzer hadn't run yet. So the other example is because the fuzzer's output hadn't been analyzed yet. There's another example where the fuzzer wasn't running on SGX systems, and so the enclave code was never hit. Warning levels may have been lowered, or some project ignored warnings, or the fact that when writing fixes, the goal is to minimize the lines of code, not to go out necessarily and think about the problem and the design of the code that's there, but just to fix it to make this one bug go away, right? And all these things are completely normal things that happen in any kind of engineering project. Fuzzers are not perfect. The process around running fuzzers isn't perfect either, but they're great tools. I'm not here to whine about fuzzers, and there's some great talks coming up next about that. And unlike a lot of people in InfoSec that will show up and bash a vendor or make fun of a bug, I actually run an engineering team. I know what it's like. I understand priorities that sometimes, unfortunately, take over security. So it's completely okay and fine that all those bugs have happened. It sucks. It's embarrassing in a way for us as computer scientists, as people in information security. I'm not saying it's embarrassing for the developers, for the company. It's just sad that in our realm, those types of bugs happen so often. So what can we do about that? You know, should MPX have been used in the fuzzer? Should Microsoft or Google hire more people who write more fuzzers? Should we just have run the fuzzer on SGX hardware and we could find the enclave bug that way? Should we just fuzz more often so there's not such a long delay between code being written and a system called shipping and fuzzers being available? Sure, but it's time to put down the fuzzing for a second. Stop thinking about how to make the fuzzer better, how to fuzz more, how to fuzz harder. These are all good ideas, but they're not really what I want to talk about. I want to talk about some crazy ideas. For example, what if we fix the education of young computer scientists? I'm not saying, let's not do bug bounties anymore, and then let's go back to, the 1970s where nobody thought about security outside NASA and the government, the nostalgic days of, old school C programming. Although honestly, I've asked my college-aged friends, and they're still learning store copy. In the Ivy League schools where you learn C, because in the other schools, you learn some high-level language which still has something like store copy, if you even learn about strings and null characters at all. And so we need better education in schools. We need programs that teach people not just how to write codes and how to make a linked list algorithm, but how to actually make it secure. How many times have you seen someone in school write a linked list parser that checks for null pointers or kernel versus user pointers or any kind of these ideas around integrity levels or trust levels or privilege levels? It's that those boundaries are typically ignored, and so we have programs that, especially in the US, are expensive, very long, and potentially meaningless to a lot of people. Now, I know Google, for example, is apparently starting some new 6-month project where if you go to a Google type school, you don't need an official degree. If those 6 months are going to teach people, proper secure programming in an area that's relevant to their job, that's actually a great thing. If that's just going to pump out more people who know how to write fuzzers and nothing else, that's not so great. So I hope programs like that make things better and not worse. But overall, I think we need to completely revamp how comp sci is taught. Now, I don't have the tools or the power to do that, but if some of you do, I think it's important to think about how education can help. Another area is licensing and training, which is a taboo if you ever mention this in computer science, right? Think of someone in mechanical engineering and think of the equivalent of the bugs I just showed you, where you're not checking the length of an array. What would a bug like that, what would the equivalent of that be in mechanical engineering as part of a bridge, right? Someone's building a bridge between, San Francisco and Oakland, and they have that kind of mechanical engineering level bug. That's gross criminal negligence in that field to have a bug in your design of that type. Or remember high school, right? When we all learned when an object is in free fall and, acceleration is exactly gravity. Now, in aeronautics, when you're, figuring out an object falling in the air, you're not just using that plane equation, right? You're taking into account air resistance, friction, and a million other variables. You'd be stripped out of your license if you just took gravity as acceleration and factored nothing else in the fall of that object. Now, I'm not saying that to run a compiler you need a license. People always jump to that straw man. Oh, so you're saying you can't write code if you don't have a license. Well, where's the innovation going to happen? Where are the people in their garages going to tinker on stuff? I think that's great. And I'm not saying anybody should take that away. But maybe if you're, I don't know, on the kernel team of the 20 people that are allowed to write code that powers the operating system that runs 3 billion devices, maybe, just maybe on that team, there should be a slightly higher standard. Maybe not everybody, without some additional training, without some additional responsibility, without some type of, responsibility, training, and so on and so forth should be allowed to write that kind of code for a large company, right? Take pilots, for example, right? They graduate from flight school. That doesn't mean they're allowed flying any plane they want for a large commercial airliner. Yes, they can go buy their Cessna and fly and have fun with it. You want to fly with 400 people behind you? You got to be licensed to fly that plane, buy some airline company that's working with you, and you fly that plane and that plane alone, unless you want a license for another plane as well. And once you can fly that plane, you got to keep reading about it, and you got to keep training on it and going back to the sim every year. In comp sci, you get your degree, and then you can go write kernel code on 3 billion devices, and if something goes wrong, it's okay, the bug bounty is going to catch it. I'm not sure that's how things should be. And I know that's a very controversial statement because people get very, very adamant about, licensing and government oversight and things like that. I'm not suggesting all those things, but maybe there's a gray zone between what we have today and, something a little bit stricter in certain realms, in certain domains, in certain types of code that people can write. And what about incentivizing creativity? Again, I'm not saying don't do bug bounties. And I'm not saying reverse engineering, which I did for most of my life and I'm still doing, isn't creative. It is a creative process to find, to reverse the right thing behind what you're looking at. But it is fundamentally a process of taking something apart. And so if you're being paid $300,000 a year to take something apart, and you're being paid $30,000 a year to build something, no one's going to build things anymore. People are just going to take things apart. And at some point, there's going to be nothing left to take apart. And yes, our society has lots of difficult, manual, laborious jobs that unfortunately are very, paid very little, and jobs that are blue collar and easy, paid very highly. Typically, those correlate with some level of education. They correlate with various things, but they're typically not inversely related to each other's, right? The opposite, low wage job isn't somehow directly related to the high paid job and vice versa. So it's kind of weird that the jobs that, rely on finding flaws in the job of someone else are paid 10 times more. And again, we probably need some way of incentivizing the creation as well. Otherwise, what will happen, in a decade or who knows when, just like, the COBOL programmers, were suddenly getting paid $500,000, what are the C programmers of 2040 going to get paid $2 million a year because there's nobody left to write C code? I mean, that'd be great for me, I guess, but I don't think we want to be heading down that road. So in conclusion, look, I realize we live in a very highly polarized society where people really want to latch on to something and take it to an extreme. Alex's talk was all about how fuzzers are bad and bug bounties are bad. And to run a compiler, you need to have a PhD and a license from the government. I'm not saying that. I'm just saying maybe we're over-focusing on finding bugs and better ways of finding bugs, why we didn't find enough bugs, how to find more bugs, how to build systems where bugs don't really matter and exploits are hard, and what's the right economic model of how much to pay for bugs. At the expense of finding out ways, how do we incentivize humans to write less bugs? How do we train and teach people to write less bugs? How do we create compilers, libraries, and computer science paradigms that make it harder to write bugs? How do we maybe even have less humans writing code, aka writing bugs? And maybe the emergence of Rust as a systems language and Microsoft's interest in it, maybe the emergence of bounty programs that are now paying for the fix, not just for the bug, are good signs that some people are listening and are heading in this direction. But I figured I'd give it one last try to try to push this message that although offensive security is great, and I do it all the time, and I don't want to sound like a hypocrite, it isn't the only thing that's out there. And I think we do need to try harder to find ways to get humans to write better code and to shepherd their code better, and to reduce the number of bugs that we have out there, not just to mitigate them, not just to work around them, but to try through tooling, through education, through all sorts of other ideas that you folks might have to reduce that. So I want to thank you all for listening. I hope this gives you some food for thought. That you can all go tweet Alex Hates Fuzzers, and I'll stick around for the Q&A. Thank you very much.